Hello everyone. Today we will go over how to convert from rectangular coordinates to polar coordinates. So first, we will derive some formulas to convert from rectangular to polar, and then we will go over some examples. All right, so we know rectangular coordinates are written in x value and y value. X as the horizontal shift and y as the vertical shift. And polar coordinates are written in r and theta. R is the radius of a circle, and theta is the angle from the x-axis. Right, first let me draw a graph. Let's say we have a point here. If you want to write this point in rectangular form, we will obviously label this as x and y. And how do we get this? We go horizontally and then vertical. This is the y and this is the x. So this is how we would naturally label this point. But what about in polar form? In polar form, we will first check the radius with r value, and then theta, which is the angle. So this is two ways of labeling this coordinate. But from this graph, do you see a relationship? We can see that this is a right angle. With the Pythagorean theorem, we can say that r squared equals x squared plus y squared. Why? Because we can see this is a right triangle with this as the hypotenuse, this as its two legs. So we can use the Pythagorean theorem to write this equation. Then we can square root on both sides. We get r equals square root of x squared plus y squared. So this is one equation that we can use to convert from, to find the r value from rectangular coordinate. But what about theta? So for theta, we can use a trig identity. We can use tangent theta. Now what is tangent of theta equal to? We know a tangent of an angle equals to its opposite over adjacent. So here, this is theta, its opposite is the y value, and its adjacent is the x value. So tangent of theta equals y over x. To isolate theta, we can take arctangent, the inverse function of tan, to get theta equals arctan of y over x. This is the formula that we will use to find theta using a rectangular coordinate. write these down and we will look over some examples. Now we will go over some examples. Let's say a point 2 and 2 square root of 3. First of all, let's see what quadrant this point is. Just for us to visualize where this point would be. So both of these numbers are positive. So we know this is it. This is in the first quadrant. And the point is somewhere right here. This is just for us to visualize so that we can figure out where theta is. Like what is our theta? So now we need to find our R value and theta. Now we can use the notes from before to find our R and theta. So to find the R value, we can see R equals square root of x squared plus y squared. You guys have this. So now all you have to do is plug in the x values and the y values from the coordinate. So this is 2 squared plus 2 square root of 3 squared, which comes into square root of 4 plus 12 square root of 6, which also equals square root of 16. And we know square root of 16 is 4. So we got our R value, which is 4. Now we have to find theta. So if we find theta, we can use the equation from before. Theta equals arctan of y over x So now we can plug the points in, plug in the x and y value. We can simplify the two. The theta equals arctan of square root of 3. Now from here, you can use a calculator to find arctan of square root of 3. If you know the unit circle, you could probably write the answer without the calculator, but it's your choice if you want to write in radians or degrees. It's just your preference or your teacher's preference. So set your calculator accordingly. You will find that arctan of square root of 3 is either pi over 3 radians or 60 degrees. Whichever one you prefer. But we need to check if this is the right angle. What do I mean by this? We know 60 degrees is in the first quadrant. 60 degrees is somewhere like here. So it is in the first quadrant. And we know our coordinate is also in the first quadrant. So our theta is 60 degrees. or pi over 2 radians, whichever one you prefer. So this is how we converted from rectangular coordinate to polar coordinate. But what if our angle theta does not correspond to our coordinate? What if it's not in the same quadrant? We will look over the next example to understand what to do then. Let's say our coordinate -3, 4. So again, let's see what quadrant this is in. -3 is to the left side and 4 is upwards, so it's somewhere right here. So it's in the second quadrant. Keep this in mind. Now let's find the R value. We can use the same equation as before. R equals x squared plus y squared. Now we plug in the points. X is -3. And y is 4. So this is also square root of 9 plus 16. 9 plus 16 is 25, so square root of 25 is 5. We know our R equals 5. Now what is the theta? So to find theta, we can use the same equation as before. Theta equals arctan of y over x. You guys should have this. So theta equals arctan of 4 over -3. Now I can use my calculator to find the arctan of 4 over negative 4 over 3. So I got -53.13 degrees. But now notice this. Our theta is -53.113. If we see the graph here, if our theta is negative, this means it goes clockwise. So it will go somewhere right here. This is the fourth quadrant. But as we know, our original coordinate is in second quadrant. So we either have to go counterclockwise this way or clockwise here. So how do we do that? We can simply add 180 degrees. or subtract 180 degrees. In this case, I will subtract 180 degrees because we're going clockwise, this direction. So this comes out as negative 233.13 degrees. Now, negative 233.13 degrees is in this quadrant, in second quadrant. So our real theta is negative 233.13 degrees. So our polar coordinate is 5, negative 233 degrees. You can round it however you want. So this is our coordinate. But what if you want your theta to be positive? If you want your theta to be positive, you will add 180 degrees instead. Instead of subtracting, we will add 180 degrees. Plus 180 degrees. We're adding 180 because we want our theta to be positive, so we want it to go counterclockwise. This gets us 126.87. Or 126.9. Either one works. With the negative 233, you're simply going clockwise and you will reach this point. And with the positive theta, with 126.9, you will just go counterclockwise and you'll still reach the same point. So it just depends which one, in which form you want to write as. Both of them works. So it could be 5, 126, or 127 degrees. You can round it however you want. So that's why we need to be careful in which quadrant our point is. Because our tangent, this function, our tangent, will only give you points from the first quadrant and the fourth quadrant. It will only give you the answer from the first quadrant and the fourth quadrant. So you have to either add by 180 degrees or subtract 180 degrees to find the real theta value, at the accurate value of this coordinate. Let's look at another example so that you can get a hang of how to convert a rectangular to polar. I know it might be a bit confusing on how theta works, but we will see. Let's look at another example. Let's say 3 negative square root of 3. Again, as I said before, let's see what quadrant this point lies at. we know, we can see that our x value is positive, but our y value is negative. So it's in the fourth quadrant. Somewhere here in the fourth quadrant. So let's find the r value. We can use the same equation as before. We plug in the x value and the y value. 3 squared plus negative square root of 3 squared. You could have the equation. So r equals 9 plus 3, because square root and square cancels out. R equals square root of 12. You can keep it in this one, or you can simplify further. This can be written as square root of 4 times 3. So r equals 2 square root of 3. Now to find theta, we can use the same formula. You can have that formula, theta equals arctan of y over x. All you have to do now is plug the values in. So our y value is negative square root of 3, and our x value is 3. Now you can use your calculator to find theta. If you know the unit circle, you would know that this value is negative pi over 6, or negative 30 degrees. Now, in this case, we can see that, look at negative 30 degrees. Since it's negative, we go clockwise, and you actually end up in the fourth quadrant. And our original point is also in the fourth quadrant. So we know this is the answer. This is the theta. We can write it in radians or in degrees. But what if you want your theta to be positive? If you want your theta to be positive, as I said, add 180 degrees. So negative 30 degrees, add 180 degrees. But for you get 150 degrees for this one. And 150 degrees is less than 180, so it's somewhere in the second quadrant. So add 180 degrees again. So now you get 330 degrees. So basically you added 360 degrees. This is also the answer, but the difference is that this is in negative theta and this is in positive theta. In radians, this would be 11 pi over 6. Whichever one you prefer, whichever one your teacher wants you, it's your choice. So in polar form, it will be 2 root 3 and 330 degrees. or it could be negative 30 degrees, or negative pi over 6 radians, or 11 pi over 6 radians. But you get it. This is how you convert from rectangular coordinates to polar coordinates.